All right, so the next thing we're going to talk about is contingency tables. And I just want us to see that probability notation and all the different formats that it can have in part 4 for something we were already familiar with, a contingency table. So we have this contingency table which has gender and how happy people are in their marriage. And then we have some questions. So just like when we first saw contingency tables, my recommendation is that you just go through and for each of these, come up with a fraction for what you think is the correct value for these different probabilities. Don't worry about putting this in a calculator yet, but pause the video, see if you get these correct. All right, so the first one we have male, very happy, so very happy, male. And then we have that keyword that we saw back on exam 1 and in part 2 of and, meaning that we want people who are both male and very happy. So we're interested in these 220. And then our whole that we're interested in is a randomly selected married adult. So out of all 603, we're looking at 221 of them. That's our probability. All right, the next one says very happy, nothing about being male or female. So now I don't care about male or female, and I want to go all the way down the very happy column until I find all of the very happy people. So 370 out of the 603. And I'll skip the third one for a second. I'll go to the fourth. Fourth one has very happy, has male again. So it has both those things from before. But you'll notice instead now there's this word given. So this last part of the sentence says, given they are male. So that means that we know the person is male. We know we're in this subset. Everything else in this table does not matter. So that is our whole, the 325 males. And then what's the probability of those males of the person being very happy? Well, that's 221. Make it a little smaller so I can fit everything. Cool. So the only one that we hadn't seen before. Given what we'd seen before, usually we had it with an of back in part 2. But we never saw the or. So let's chat about that one. Again, we have male, we have very happy. And if you did not pause the video, I want you to try to figure out how you would find this on your own before you jump and have me show you. Because if you can figure out how to do this on your own, you're in a much better spot. But if you're doing this, we want everyone who's male. We want everyone who's very happy. So there's two ways to do this. One is we can just highlight all the people who count as part of these groups, right? Male or very happy. And I always get students who ask, does or include the intersection? Is this value, these 221, are they included? And the answer is yes. Being both does not mean that they're not part of the or. So that's one option, is just add those all up. 221 plus 95 plus 9 plus the 149. If you're really clever, I've had a lot of students say we could take all the males and then just add the very happy females to that. It's the same thing, it's just adding these first. But we're going to see eventually a nice little formula, and that's a different way to do it. I've also had students tell me, well, we should take all the very happy people and all the male people and add them together. One of my old CT, actually, Eli, he was the one who said this, I think, in class. He said we're supposed to add them together. Maybe it was somebody else. He's like, but that number is, if I divide by the 603, because again it just says a married adult, this is going to be bigger than 1, and probability can't be bigger than 1. There are all these females who aren't happy. So how am I going to deal with this? And this is because if we add these two pieces together, we're double counting this 221. So if we subtract off that 221, then we'll get the same thing as if we just added all those pieces together. So while all of these are completely legitimate answers for your probabilities, I tend to like these given as decimals, rounded to 4 decimal points. So I'll just go ahead and write those in for us. And 0.68. Perfect. But fractions, decimals, and percents are all the same thing, so I'm completely fine with any of them as an answer. I will say that if you do want to give me percents, my 4 decimal rule that you saw at the beginning of the last test, you only have to give me 2 on a percentage because technically the percent is a decimal. So that would be the same thing. So just throwing that out there. All right, so why this page actually matters is not for this calculation, but for the notation. So we have 3 or 4 different notations here, and these are the 4 different things that you're going to see in part 4. So probability, right? That's what we're looking for. The probability we want is male and very happy. So we could use an M for male. We can use a VH for very happy or a V, it doesn't matter. And then you have 2 options. You can literally just write the word and. That's completely okay. Or if you want to be mathier about it, the mathematical symbol for and is the intersection symbol. It's like a big upside down U. It doesn't matter though. You'll see I do give you a formula sheet starting with exam 2, and I literally have both of these things written with an equal sign. So whichever notation you use, you'll be in good shape. All right, the next one, we're talking about the probability of just nothing about males. This is just very happy by itself. We have the probability of male or very happy, which again, we can just use the word or. And then the mathematical version of or is the union notation, which is the big U. And then the last one is the most important one because this is the heart of our inference later, and it's one that I test many times on the test. The last one, the probability of, okay, this one actually looks like this. Very happy given male. And you may have seen this notation before, whether or not you know it. Whatever's behind the given line is what we're going to put behind given is what we're going to put behind the line. And the way you may have seen this in math is in like set builder notation. Whenever you're dealing with inequalities, one of the ways to express your solutions is something like this, which to a math person this says the set of x as long as or such that x is greater than 2. This is basically telling you that whatever comes next is a rule, it's something given, it's known. So we use the same notation here, except for instead of saying the set of all these things, we're saying the probability of very happy given that we know that the person is male, given this information. So again, super crucial. These are 4 different types of probabilities. This is what we call a joint probability, a marginal probability. This one doesn't really have a special name. It's the probability of a union, because that's what we're talking about with or. And then, of course, we have our conditional probability. So again, like I said, these 3 we saw before in part 2 and are nothing new. The only thing new is our notation.